So here in the insert method, we're going to extend this logic and print what kind of rotations we need here. Now, before we get started, I want to extract this logic into a separate method because our insert method is getting a little bit too bulky. And as we extend this logic, it's going to get even worse. So I'm going to declare a private method, private void balance. I'm going to give it an AVL node called root. Then select these few lines and bring them down into our new method. In case you're wondering, the shortcut that I used is Shift, Alt, and down. Okay. Now, back in the insert method, after we set the height, we're going to call the balance method and give it a root object. Okay. Now, we're going to work on this method. First, I'm going to delete this line because the balance factor variable is grayed out, which means we haven't used it anywhere. So delete. Now we have two conditions. If the root is left heavy or right heavy. I'm going to work on this scenario first. So let's add braces and delete this line. Now, what should we do here? We should look at the balance factor of the right child of the root node. If it's greater than 0, that means we should have an additional right rotation. So if balance factor of root, the right child, is greater than 0, we're going to print right rotate on this node, root.right child. So root.right child.value. Okay. Now, because our root is right heavy, we should always perform a left rotation on the root node. So here we print left rotate plus root.value. That's it. Now let's look at the other scenario. If the root is left heavy. Here we're going to get the balance factor of the left child of the root node. So we're going to do the opposite of what we're doing over here. Take a look. If balance factor of root, the left child, is less than 0, that means we should do a left rotation on this node. So print left rotate plus root.left child.value. So it's exactly the opposite of what we are doing over here. Okay. Now, because our root is left heavy, we should always perform a right rotation on the root node. So print right rotate plus root.value. That's all you had to do. Now let's test this logic. So back to our main class. Here we have a right skewed tree that looks like this tree over here. So when we run our program, we should see left rotate 10. Take a look. There you go. Now let's look at this scenario. So I'm going to add 10 first, then 30, and then 20. Now let's run this one more time. So first we should do a right rotation on the 30, followed by a left rotation on the 10. And that is exactly what we were expecting here. So now that we know what kind of rotations we need to perform, it's time to implement these rotations. And that's what we're going to look at next.